On March 15, 2023, commercial diver Marcus Chen descended 500 feet below the North Sea. He wouldn't breathe surface air again for 34 days. For the next month, Marcus lived in a pressurized steel chamber, smaller than a cargo van, with 2 other men, welding pipelines 8 hours a day in absolute darkness. His employer paid him $2,000 per day. By the time he emerged from decompression, he'd earned $68,000 and lost 7 pounds despite eating 5,000 calories daily. Every 100 feet of depth adds another full day to your decompression time. Working at 500 feet means spending a minimum of 5 days trapped in a chamber after your job ends, waiting for nitrogen to slowly leave your tissues. How do these professionals transform Earth's most hostile environment into a workplace? Chapter 1. The Economics of Pressure. Before we get into how they survive, let's learn about the offers these divers receive first. They earn more in 1 month than most welders make in a year. Experienced saturation divers command daily rates between $1,500 and $2,000. But the true transaction involves trading your physical freedom for financial reward, accepting imprisonment as the cost of reaching depths where few humans can work. Any dive deeper than 150 feet becomes inefficient using traditional methods. A bounce dive, descending from the surface, working briefly, then returning, would require hours of decompression for just minutes of actual work. The human body absorbs nitrogen from breathing compressed air, and that nitrogen must be released slowly or it forms potentially fatal bubbles in the bloodstream. At 200 feet, a 30-minute work period demands 2 hours of decompression. At 400 feet, those same 30 minutes require 5 hours hanging on a decompression line. Saturation diving solves this problem. If decompression is unavoidable, do it only once. After about 24 hours at any given pressure, human tissues become fully saturated with inert gases. Once saturated, staying another day or another month requires the same decompression time. A 2-day job at 500 feet and a 28-day job at 500 feet both demand approximately 6 days of decompression. This transforms the economics completely. Companies can keep divers at depth for weeks, completing massive projects that would be impossible with daily decompression requirements. The infrastructure supporting this work costs millions. A dive support vessel equipped for saturation operations runs $150,000 to $500,000 per day to operate. The saturation system alone, a complex of pressurized living chambers, transfer chambers, and life support equipment, represents a $10 million investment. The diving bell that ferries workers to the sea floor costs another $2 million. These vessels carry crews of 50 to 100 people, but typically support just 6 to 12 divers in saturation at any given time. For the diver, calculation is crucial. 28 days in saturation at $2,000 daily yields $56,000. Add 6 days of decompression, also paid, and the total reaches $68,000 for 34 days of complete isolation from the normal world. But those 34 days mean missing birthdays, anniversaries, and every ordinary moment of life on the surface. The money compensates for more than just risk. It's payment for accepting temporary erasure from normal existence. The depth itself becomes currency. Insurance companies classify any dive below 50 meters as deep diving with elevated premiums. Below 100 meters enters extreme exposure territory. The deepest saturation dives on record reached below 700 meters, over 2,300 feet, where the pressure equals 70 times atmospheric pressure at sea level. At these depths, conventional diving equipment fails. Breathing gas becomes so dense, it's like breathing liquid. The human body operates at its absolute limits. Chapter 2. Engineering the Impossible. Creating a dry workspace, 500 feet underwater, requires defeating fundamental physics. Water pressure at that depth exceeds 220 pounds per square inch, enough to crush an empty aluminum can to the size of a thimble. Yet hyperbaric welding demands exactly that, a dry, pressurized environment where welders can produce the same quality joints they'd create in a fabrication shop on land. The solution? Well, engineers design custom habitats, sealed chambers that clamp around the section of pipeline or structure needing repair. These habitats range from coffin-sized boxes for small repairs to room-sized complexes for major construction. Once positioned and sealed, powerful pumps purge all water from the habitat's interior, replacing it with a carefully controlled breathing gas mixture. The process begins days before any welder enters the water. Naval architects calculate the exact dimensions needed. Engineers design custom sealing systems that can accommodate irregular surfaces, accounting for marine growth, corrosion, and structural deformation. The habitat must withstand not just the ambient water pressure, but also the differential pressures created during the purging process. A seal failure at 500 feet would create an implosion powerful enough to kill anyone inside instantly. Transportation is another challenge. The 10-ton habitat is lowered from the support vessel through strong currents that can push it sideways. Despite its massive size, it must be positioned within centimeters. Divers use thrusters and chain hoists to guide it into place, an underwater ballet of heavy machinery. Once in place, the seal must be flawless. Divers fit inflatable gaskets over surfaces coated in decades of marine growth, then inject sealants that cure underwater and hold against pressure. The attachment system has to endure currents strong enough to tear the habitat away during storms. The habitat's atmosphere needs strict control. At these depths, workers breathe a helium-oxygen mix that must stay in balance. Too much oxygen can trigger seizures, too little leads to suffocation. Humidity must be kept low to avoid condensation that disrupts welding, while temperature control is vital since helium pulls heat from the body far faster than air. Inside this artificial bubble, welders work with equipment worth hundreds of thousands of dollars. Orbital welding machines that rotate around pipes, creating perfect X-ray quality welds. Gas tungsten arc welding systems that would be at home in an aerospace factory. The weld quality must meet the same codes and standards as onshore construction. The ocean makes no allowances for inferior joints. A failed weld on a high-pressure gas pipeline could cause an explosion visible from space. Chapter 3. The Physics of Survival. At 500 feet below the surface, the human body exists in an alien state. Every biological system operates under conditions evolution never anticipated. The pressure compressing your chest equals the weight of a concrete truck balanced on your ribcage. Breathing requires mechanical assistance. The pressure differential makes it impossible for human muscles alone to expand the lungs. Nitrogen becomes a poison at these pressures. The narcotic effect, similar to alcohol intoxication, begins around 100 feet for most people. By 200 feet, the impairment equals several shots of whiskey. Beyond 300 feet, nitrogen narcosis can cause hallucinations, panic attacks, and complete loss of judgment. The solution is replacing nitrogen with helium in the breathing mixture, creating the characteristic Donald Duck voice that makes saturation divers unintelligible without electronic unscramblers. Helium prevents narcosis, but brings new risks. Its high conductivity drains body heat so quickly that divers rely on heated suits as essential life support. Hot water at 104 to 106 degrees Fahrenheit circulates through tubes in the neoprene, pumped at 3 to 4 gallons per minute from the surface or diving bell. If that flow stops, a diver has only minutes before hypothermia disables them. Delta P, or differential pressure, is one of the deadliest hazards. When water at different pressures meets, the suction force can be overwhelming. Just 10 psi across a 6-inch pipe creates 700 pounds of pull, far beyond human strength. Found near intakes, dam gates, thrusters, or broken pipelines, it's invisible until it strikes, capable of dragging a person through gaps too small for their body and crushing them in seconds. Seawater's conductivity makes underwater welding extremely dangerous. Welders use 300 to 400 amps, and electricity can pass through the diver's body if the insulation fails. Direct current is used because it causes a single muscle contraction, while alternating current locks muscles in spasm. Layers of insulation and ground fault protection reduce risk, but the margin for error is zero. Decompression sickness, or the bends, is a constant threat on ascent. Nitrogen absorbed under pressure must be released slowly, guided by strict decompression tables based on depth, time, and gas mix. Rising too fast from 500 feet makes nitrogen bubble in the blood like shaken champagne, causing joint pain, strokes, or even paralysis. Chapter 4. The Sensory Void. In the waters where underwater welders work, visibility is often measured in inches. This isn't the crystal-clear ocean of tropical vacation photos. Commercial divers operate in harbors thick with silt, rivers churning with mud, and industrial sites contaminated with decades of runoff. The helmet lights penetrate perhaps 2 feet before the murk swallows their beam. Most work happens in what divers call black water, zero visibility conditions where you cannot see your hand touching your faceplate. Training starts in blacked-out pools with masked students working blind. They learn to take apart and reassemble gear by touch, recognizing valves, fittings, and bolts through thick gloves. Over time, their hands become their eyes, able to feel a hairline crack in steel, tell 7/8 inch from 15/16 inch bolts, and know thread direction on hidden fittings. Underwater welding demands a new approach. On land, welders rely on sight, but in darkness below, they work by sound and feel. The arc's hiss shifts with distance, while vibrations through the electrode reveal penetration depth. Divers count seconds to keep a steady pace, imagining the weld bead forming under their unseen hands. In darkness, communication is vital. The supervisor sees little beyond silt and brief flashes of equipment, so the diver must narrate everything they feel and do. Helium distorts speech into squeaks, and electronic unscramblers only partly fix it. Often, divers rely on shorthand and familiarity with their partners to understand each other. Inside the saturation chambers, other senses fail. The high-pressure helium environment kills taste and smell almost completely. Food becomes mere texture and temperature. A steak tastes identical to cardboard. Coffee might as well be hot water. The galley sends down hot sauce by the bottle. It's the only flavor strong enough to penetrate the sensory dampening. Divers joke about the SAT diet, losing weight despite consuming 5,000 calories daily, because eating becomes a chore when food has no flavor. The constant pressure creates phantom sensations. Joints ache from nitrogen accumulation in the synovial fluid. The inner ear struggles to maintain balance, creating persistent vertigo that veterans learn to ignore. Tooth fillings compress differently than bone, creating stabbing pains that dentists on the surface can't diagnose. The humidity, kept high to prevent dangerous dehydration in the helium atmosphere, causes skin to remain perpetually damp, leading to infections and rashes that antibiotics struggle to control in the pressurized environment. Chapter 5. The Accumulating Toll. By day 21 in saturation, the human cost compounds beyond simple fatigue. The body, never designed for prolonged pressure exposure, begins breaking down in subtle but progressive ways. Joint fluid thickens from dissolved gases, making every movement feel like grinding sand in the knees and shoulders. The medical term is compression arthralgia, but divers simply call it the bends that haven't happened yet. The narrow bunks in the saturation chambers force occupants to sleep inches from curved steel walls that sweat with condensation. The life support machinery never stops. Pumps circulating gas, scrubbers removing CO2, heaters maintaining temperature, creating a mechanical symphony that penetrates dreams. Many divers report the same nightmare, the chamber flooding while they're trapped in their bunk. They wake gasping, checking the humidity levels, confirming they're still dry. Imagine 3 men sharing a space smaller than a prison cell, unable to leave, unable to have privacy, unable to escape each other's sounds, smells, and moods. Veteran SAT divers talk about chamber fever, the creeping paranoia that develops after weeks of confinement. Small irritations explode into rage. A colleague chewing too loudly becomes grounds for a fight that could end careers. Companies employ topside psychologists who monitor chamber communications, listening for signs of breakdown. In addition, reaction times slow by 15 to 20% after 2 weeks in saturation. Fine motor control deteriorates. Tasks that took 30 minutes on day 5 require an hour on day 25. The danger multiplies because the hazards remain constant while human capability diminishes. Hydrogen and oxygen from the welding process accumulate in confined spaces, creating explosion risks that require constant vigilance to prevent. A moment's inattention to ventilation procedures could ignite a blast that would kill everyone in the habitat. Equipment failures become more likely as maintenance schedules stretch. The hot water system that keeps divers alive operates continuously for weeks. Pumps wear out. Heating elements corrode. Umbilical hoses suffer abrasion from constant movement across rough surfaces. Each component has redundancy, but backups can fail too. When primary systems fail on day 25, the tired crew must respond as quickly as they would have on day 1, despite degraded reflexes and clouded judgment. The medical issues compound. Ear infections flourish in the humid environment, potentially rupturing eardrums if pressure changes too quickly. Skin infections spread where wetsuits chafe. Dehydration becomes chronic despite forcing themselves to drink. The helium atmosphere pulls moisture from bodies faster than they can replace it. Blood samples taken during saturation show elevated stress hormones, suppressed immune function, and markers of systemic inflammation. The body treats prolonged saturation as an ongoing injury it cannot heal. Chapter 6. The Reckoning Day. 28 ends not with celebration, but with anticipation of the trial ahead. The work is complete, miles of pipeline welded, structures repaired, inspections finished. But freedom remains 6 days away, hidden behind the iron mathematics of decompression. 1 day per 100 feet of depth, plus a safety margin. The ascent from 500 feet to sea level must happen in precisely controlled stages, each increment calculated to prevent nitrogen from forming bubbles in tissues. The decompression schedule reads like a railway timetable designed by physicists. Every 4 hours, the life support technicians reduce chamber pressure by a specific amount, perhaps 10 feet of seawater equivalent. The divers feel nothing as it happens, but their bodies begin the slow process of releasing stored gases. Too fast, and they'll experience decompression sickness. Too slow, and they're unnecessarily prolonging confinement. The margin for error is measured in minutes and inches of mercury. During decompression, the diving company maintains full crew costs. The DSV still burns $200,000 worth of fuel daily, the support staff remains on duty, and the life support systems continue operating. A single diver's decompression costs the company roughly $50,000 in operational expenses. This economic pressure creates temptation to rush, to shave hours off the schedule. But the consequences of yielding to that pressure are written in the paralyzed bodies and ruined careers of divers who surfaced too fast. The physical symptoms begin around day 3 of decompression. As nitrogen leaves the tissues, it creates sensations like carbonation under the skin. Joints pop and crack with sounds audible to chambermates. Some divers experience skin bends, patches of itching so intense they leave bloody scratches. The medical lock allows doctors to pass medications into the chamber, but many symptoms simply must be endured. Psychological challenges intensify during decompression. The work that provided structure and purpose is finished. Now there's nothing to do but wait, trapped with the same people who've shared your every moment for a month. Some chambers have small viewports to the outside world, and divers spend hours staring at glimpses of sky, counting seabirds, watching weather they cannot feel. Others prefer chambers without windows, finding the reminder of an unreachable outside world more torturous than isolation. The final day arrives with an anticlimactic procedure. Life support technicians run through checklists, monitoring for any signs of decompression sickness, blood pressure, joint mobility, and neurological function, all assessed before the final pressure reduction. The last few feet of pressure release take hours, the human body reluctant to surrender its stored gases, even at shallow depths. Then, finally, a technician spins the wheel that unseals the chamber door. The first breath of natural air hits like a drug. Divers describe the sensory overload. Colors seem impossibly vivid after weeks under fluorescent lights. Sounds have texture and depth lost in the helium atmosphere, and smells assault nostrils dormant for a month. Some men cry at the sensation of wind on their skin. Others stand paralyzed, overwhelmed by the sudden expansion of their world from a steel tube to an infinite horizon. The offshore infrastructure that delivers energy to billions exists because individuals accept this bargain, descending into darkness to perform work that cannot be done any other way. They don't ask for recognition. The paycheck provides that. But understanding the true price of depth reveals that civilization's comfort depends on individuals willing to work where survival itself requires excellence.